Hi everyone. So today we are going to be comparing linear to exponential functions. So we've learned a lot about both. And yesterday we briefly talked about simple interest, which is linear, versus compound interest, which is exponential. Now we're going to be looking at tables of values. And when you look at a table of values, you can tell by the pattern of the numbers whether the function is linear or exponential. In a linear function, as the x values increase by 1, so if you'll notice every time my x values are getting 1 higher, the y values will be increasing by some constant amount. So if you notice from 4 to 7, 7 to 10, 10 to 13, it keeps increasing by 3. Okay, this is called a common difference, which we're going to be talking about more this year. That common difference is, if you have a common difference, that tells you that this is linear. Okay, so if someone just asks you, like, is this linear or is this exponential? If you have the same value being added every time from one y value to the next, then that's an indication that it's a linear function. Okay, and that common difference happens to be the slope of the line, right? So for every increase, it's a constant increase of y over x. That's the whole idea of rate of change. So if somebody asked you to write the equation of the line, so remember y equals mx plus b, slope is that common amount that they keep adding, so 3 times the x value. And then you can look in the table, oftentimes you'll be given a y-intercept, or you can calculate it. We know how to calculate the y-intercept, but in this case, in a lot of these problems, they give you the y-intercept. Remember, the y-intercept is where the x value is 0, okay? Where x equals 0, that's your y-intercept. So you can usually just find it in the table and show it there. If it's not in the table, then you do a calculation where you solve for b, plugging in one of the x and y values as we've done in the past. Okay? When you look at a table of an exponential function, you'll notice that as the x increases by 1 each time, same idea, as x increases by 1 each time, if you look for a common difference in the y's, there is no common difference. They don't keep adding the same amount. 2 plus 4 is 6, and then you would have to clearly add 12 to get to 18. It's not the same amount being added every time. However, you'll notice that 2 times 3 is 6, and 6 times 3 is 18, and 18 times 3 is 54, etc. Right? So if you keep multiplying by the same value, that's an indication that this is exponential. In an exponential function, the y values, and we've seen this when we did the graphs, right? Or when we did like a basic y equals 2 to the x power, all the y values kept doubling. Or y equals 3 to the x power, all the y values kept tripling. So that tells you if the y values keep multiplying by the same value, that it's an exponential function. This common amount that keeps getting multiplied is called the common ratio, which we're going to see again later this year. Oop, not rational, but ratio. It's the common ratio. And that is your b value in the exponential function. This is your b value in the exponential function. Remember, a is the y-intercept, and b is the, it's 1 plus the growth rate, but it's also the common ratio. Okay? So if I'm asked to write the equation of this line, I'm going to write y equals a is my y-intercept. So again, look for the y-intercept where the x value is 0 is the y-intercept. So 2 times my common ratio is 3 to the x power. And that's how I would write the equation based on the table. Again, keep in mind what this means. It means that the y values are tripling every time. What percent increase is that? If somebody asked you what percent increase, that's a 200% increase, right? Because it's increasing by 200% in order to triple. All right, now, look at the next example. The first thing I usually do is I look for, because the easiest one is common difference, right? So I look to see, are they adding the same amount every time? So 16 to 20 is 4, 20 to 25 is 5, so they're not adding the same amount. This is not linear. So if it's exponential, then they're multiplying by the same amount. But I can't easily figure out 16 times what is 20. Maybe you can. maybe you can't. Most students at this age are not figuring out what that is. So think to yourself, how can I figure out what they multiplied by? 16 times what is 20? You take a y value, the second y value, and divide by the first one. So if you do 20 divided by 16, you could use fractions. 16 goes into 20 once with a remainder of 4, so 4 over 16 is 1/4. Okay, you can also divide in your calculator, you'll just get 1.25. So if you divide any y value by the preceding y value, the one that comes before it, you'll get that amount that it was multiplied by, that common ratio. So it's 1.25. Now I'm going to check it with the others. If I divide 20 by 25, 25 by 20, do I get 1 1/4? I do. 20 times 1.25 is 25. And this continues on and just double check it. Okay, so this common ratio tells me this is exponential. I can see the y-intercept here at 0, 16. So I can just write the equation. Y equals 16 is my a value times 1.25, or 1 1/4, or 5/4 to the x power. Okay. So some easy examples in practicing recognition of linear versus exponential word problems. If you read examples 2 and 3 to yourself, figure out which one's linear, which one's exponential, and if you could write an equation for each of those. Pause the video and see if you could do that. Okay, so these should have been fairly straightforward and obvious. If a gym's membership must pay a $50 for the membership plus $3 each time they use the gym. $3 each time they use the gym is your slope. This is linear because it's the same amount each time. And $50 is your initial value. So this should have struck you as linear. This is y equals 3x plus 50. Okay, whereas the example of owls in the wild, you start out with 20,000 owls, but every decade the number of owls is halved. So it's half of the preceding year. So it's not the same amount each time. It's half of the first year, then after that first year, it's half of that new amount, and then half of the following new amount. So this is exponential. So I'm going to write for the first one, linear. This one is exponential. So it's going to be y equals 20,000 is my initial value for the number of owls, times, and you just, each year, half remains. So half to the x power. Okay. All right, now we're going to practice writing equations given 2 points for exponential functions. Okay, I'm going to start a new video just so I don't go over on time on this. So I will stop here and continue.